Hey class, I'm going to go over section 1.1 with you from your books where we talk about real numbers. Now, I can't be there with you right now, but why don't you go ahead and take your books out, take your notes out, and follow along this video as you would if I were in class with you, okay? So we're going to go over section 1.1, which is about real numbers. We're going to learn how to define sets and classify numbers. We're going to learn how to plot numbers on a real number line. And we're going to use inequality symbols and to order numbers. So that's going to be your greater than and your less than signs, greater than or equal to, less than or equal to. And we're going to find the absolute values of numbers as well. So the first thing we're going to start with is sets. And if you turn in your books to page 2 and page 3, that's basically what we're going to talk about here with sets, okay? So let's go ahead and start. Now, what are sets? Sets are going to be basically a list of things, all right? So a list of a category of something, all right? It doesn't matter what it is, and you can fit anything into a set. Normally, when you write sets, you write them in braces, which are these brackets here that have like a little point on them. And anytime you have a set, you can have a subset, which is basically a set that fits into the set that you've created already. So let's use a pizza party as an example. Now, in a pizza party, if you make a set of everything that you would bring to a pizza party, it would include things like pizza, drinks, music, friends. Now, you see, all of these are basically just a bunch of different things, not really super specifically categorized, but you know that you can find all of these things at pizza parties, right? What you don't find at pizza parties, or what would be like an outlier or something that doesn't belong to the set, would be something like a gorilla, right? You normally would not find a gorilla at a pizza party. Now, if we use the same example and we think about subsets, a subset would be something that could still belong to the set, right? But is a little bit more specific. So what do I mean by that? Instead of maybe thinking about just the set of the pizza party, let's think about a set of the food that you would find at a pizza party, right? So if you create a set under pizza party that still applies to pizza party but is only specific to food, right? Then you would include things like pizza. You would include things like wings, breadsticks, I don't know, whatever else you would eat at a pizza party, that would be in the subset of food that then could be found at a pizza party. Very important about subsets, whatever you have in a subset must fit into the set, okay? So if you have something in a subset, it has to be able to fit into the set that is above it, okay? Now, if we're gonna talk about sets of numbers, basically every number is either gonna be a real number or a non-real number, okay? In the real number though, that's gonna be your main set. But if you look, real numbers have many different subsets, okay? So if you see here, we have real numbers, and then the subsets are irrational and rational, and then the subsets of those are going to be non-integers and integers. The subsets of those are going to be negative integers, whole numbers, and so on and so forth, okay? But if we're looking at just real numbers as our set, then all of the things below it apply to that set of real numbers. What doesn't apply to the set of real numbers is going to be non-real numbers, or imaginary numbers, as we would call them. Now, imaginary numbers, you probably worked with those last year in Algebra 2, and that's going to be the I, okay? I, where you know that I squared is going to equal -1, and you use that when you're trying to say that inside there is a negative somewhere where there normally shouldn't be a negative, like in a square root, okay? Now, let's look a little bit further on the real number set. The real number set's going to have an immediate subset that splits into irrational and rational numbers. Now, these are both subsets of real numbers. Both of these can be fit into real numbers. Irrational numbers are going to be numbers that basically are not tangible, okay? And I'll explain that a little bit further right now. But rational numbers are going to be numbers that you can fit into, let's say, your hand or your head, okay? Now, what are rational numbers? Things like -1/2, 0, and 2/3. Rational numbers are going to be numbers that either terminate, so they have an end, or they repeat, okay? So what do I mean by that? If you have 2/3, it's actually going to be 0.666666, so on and so forth, right? If you have -1/2, it's going to be -0.5 if you're going to turn it into a decimal. A number like 4 is also going to be a rational number. a number like the square root of 64 is going to be a rational number because that's going to be 8. What irrational numbers are numbers that do not terminate, right? And do not repeat. So for example, if we write pi, if we take out our calculator and we write pi and we press enter, we get 3.141592654, right? And if we write square root of 3, you see they're numbers that keep going, but they don't repeat, okay? And that's really, really important. Numbers that are going to repeat, it means that they're going to turn into whole fractions. Now, the true definition of a rational number is a number that can fit into a fraction or that can fit into a ratio, okay? So that's the definition of rational numbers, and if they can't, then that's going to be irrational numbers, okay? So moving forward, you have the irrational numbers will end there. There's no subsets for irrational numbers. I'm sure you can make a subset like negative irrational numbers and positive irrational numbers, but we're going to focus here on rational numbers and where you have non-integer fractions and integers. And those are going to be two subsets for rational numbers. Now this one's pretty simple, right? Integers are going to be numbers that have an end before the decimal point. Okay, so basically whole numbers, but including the negatives as well and zeros, okay? Non-integer fractions are going to be basically just your fractions, what is in between each number on the number line, okay? Now integers, you can move on a little bit further and you can find negative integers and whole numbers. Negative integers are going to be anything on the number line that goes negative, right? That is an integer, so that has a definite end before the decimal point on the number line. And then whole numbers are going to be basically 1, 2, 3 all the way to infinity, including 0. Now if you're going to make a subset of whole numbers, we get to the last one, which is natural numbers and 0. So in natural numbers you have 1, 2, 3. Basically you're counting numbers, what you learn to count when you're in kindergarten or in pre-K, right? You don't start with 0 when you learn to count, you start with 1. Okay, and then you can split up into 0 as well. So this is basically the flow chart of the real numbers set, okay? Memorize this, not exactly with each and every example, but understand what numbers pertain to each category and understand the flow upward towards real numbers, okay? 0 is definitely part of real numbers. Rational numbers are part of real numbers. However, irrational numbers are not part of integers. Okay, so if it's on the bottom, it's going to fit into what is above it, okay? So let's go ahead and make sure that you understand this and that you work on example 1. And that's going to be the end of this first video, but work on example 1. It's asking you, if you have this set right here, tell me out of this set, which ones are natural numbers, which ones are integers, which ones are rational numbers, and which ones are irrational numbers. And go ahead and write them in the brackets. Sorry, in the braces. So if you're writing them in the braces, you are then making your own set. So make subsets of this set that fall under each category, okay? And then as soon as you finish that, go ahead and move on to the next video.